Welcome to all of you in our channel PSIM. Today we discuss about short question answers of Power Electronics subject 2015 summer. First question is define holding current and latching current. So holding current is defined as minimum value of anode current below which the SCR stop conducting and return from on state to off state. Holding current is associated with turn off process. So in the data sheet, if the value of holding current is given as 10 milliamp. So if the anode current reduces below 10 milliampere, then SCR is turned off. Latching current. It is minimum on-state current required to keep the device is in on condition. Or say on state after gate pulse is removed. It is associated with turn on process. The value of latching current is approximately 2 to 3 times that of holding current. Second question, write the full form and draw the symbol of GTO, MOSFET, TRIAC and MCT. Full form of GTO is gate turn off thyristor, MOSFET is metal oxide field effect transistor, and TRIAC is diode work on AC. MCT means most control thyristor. These are the symbol TRIAC 3 terminal MT1, MT2 and gate. GTO 3 terminal gate, two line, one for the positive pulse and second for the negative pulse, cathode, anode. MCT, gate, collector and emitter, and MOSFET, three terminal gate, drain and source. Next question, why gate protection of SCR required? So in the PCB there are number of semiconductor devices are mounted. If one semiconductor device is switch on, voltage across it collapse and current is established. So when semiconductor devices is on, voltage across it reduces almost less than to 1 voltage or say 1 voltage and current passing through it. So this will result in electric field collapse. This one is associated with voltage and magnetic field create. So this one is associated with current. So semiconductor devices is on, magnetic field create and electric field collapse. Similarly, when semiconductor devices is turn off, magnetic field collapse and electric field is generated. This one is associated with V and this one is associated with I. So device is turn off, magnetic field collapse and electric field is generated. So this electric field and magnetic field gives rise to induced voltage in nearby gate circuit of SCR. So there are number of semiconductor devices in the PCB. This one is 1, 3, 4, 5, 6, 7, 8. If this one is on and off, so several times on and off gives rise to induced voltage. Induced voltage in the nearby gate terminal of SCR. So these semiconductor devices are on without any gate signal. So it must be protected against such type of malfunction. So gate terminal of these semiconductor devices must be protected. Next question is, what is thermal resistance? So it is resistance offered against power flow. It is resistance offered against power flow. The semiconductor devices, its units is centigrade per watt. Give the application of chopper. The DC chopper is associated with variable DC supply. They are useful for the speed control of DC series motor, speed control of wound rotor induction motor, battery operated DC supply, battery operated variable DC supply vehicles, trolley buses, subway car, marine hoist, mine hauler, etc. due to faster response, higher efficiency, and smooth acceleration. State the condition of commutation of SCR. Commutation of SCR is done by two methods, either voltage commutation or current commutation. If the anode current fell below the holding current, if the anode current fell below the holding current, it is known as a current commutation. So anode current must be less than the holding current in the current commutation. Second one is voltage commutation. The time for the reverse voltage across SCR. Reverse voltage means negative is given to anode and positive is given to cathode must be greater than the turn off time of SCR. The turn off time of SCR is given in the SCR datasheet. Third one is dV by dt across SCR should not exceed its critical rate. If its value increases, then SCR is switched on. These are the three conditions of commutation of SCR. Another condition is when inductive load is used in the SCR. So one flywheel diode is connected across the load. One flywheel diode is connected across the load in order to turn on due to dissipating inductive energy of the load. So when inductive load is used, energy of inductance dissipate during negative cycle. So SCR is not switch off during that condition. So one flywheel diode is connected across it in order to switch off the SCR. Next question, give classification of inverter. So according to output voltage, single phase or three phase. Another is voltage source or current source. According to output waveform, square wave, pulse with modulation or quasi square wave. According to commutating component connection, series, parallel, bridge inverter. In bridge inverter, there are two types, half bridge and full bridge. According to method of commutation, line commutation and post commutation. State the application of cycloconverter. Cycloconverter is associated with variable voltage, variable frequency output supply. So it is useful for speed control of AC drive, grinding mills drive, induction heating, variable frequency supply for shipyard or aircraft, static work generation. This work means reactive work, HVDC transmission. Next question, why IGBT is most popular in the industry? So IGBT is most popular because it has a low switching losses. state the basic principle of inverter. So basically inverter consists of two semiconductor devices. The switching of semiconductor devices alternately, it generates square wave or rectangle waveform. Later it is converted into sinusoidal waveform. First we understand that what is inverter. So it is device or equipment which convert DC voltage into DC voltage into variable voltage, variable frequency AC supply. So when switch S1 is on, so this one is positive, this is negative, this one positive, this one negative. So output voltage, this is negative. When switch S2 is on, this one is positive, this one is negative. Again, this is positive, this is negative. A positive voltage is available at the load. So this type of waveform is available at the output. So basic inverter circuit consists of two switching devices. Alternately switch S1 and S2 on and off. The output voltage is available at the output. This voltage is converted in sine waveform after it, but it is available in the form of rectangle or in the form of square waveform.